After going through how to name the compounds, how to write the compounds, then how to write based on functional groups, followed by common reaction. Now we are entering into the first chapter, that is haloalkanes and haloarenes. Okay. What do you mean by haloalkanes? What do you mean by haloalkanes? That is, it's nothing but alkyl halides. That's all. It's only alkyl halides. For example, methyl chloride, ethyl chloride, phentyl chloride, something like this. When you say AR means aromatic. Aromatic means benzene. For example, chlorobenzene, bromobenzene, all are arenes. So, okay. Now, first level, what are the, when I enter into the chapter means, I will see to that I am very much interested in that, simplifying only. First, you should not learn all the reaction followed by the books or guides. Somebody may accept and they can come over. Many students cannot go through. So, what I am trying is, first level means, what are the first reactions you should learn regarding alkyl alkanes and alkyl arenes? So, okay. You see, Schwarz reaction, Dawson reaction, Hunziker reaction, but this reaction is not in your book, but it's there in state board and all. Hunziker reaction, Finkelstein reaction. Before going to these four, it may be somebody may be confused. So, better learn this one. You see, fluoride, chloride, bromide, iodide. This is the periodic followers of halogens. So, I am writing first fluoride, then chloride, bromide, iodides. What do you mean by S? S means Schwarz. Dawson, Hunziker, Finkelstein. You just learn this first letter, SDHF. So, you will not confuse in writing the other reaction. Okay. First means, S means, you know it's fluoride. You first see the reagent, AgF. You see here? When you treat in a bromide with the AgF, very simple. The F will go inside and Br will come inside. That's all. And what about the second one? Torsion. This reaction already you are learned in the common reaction. What I told you, when you treat any alcohol with thionyl chloride, the OH will be converted into Cl. But here you are seeing that we are using a catalyst like pyridine. Okay. Then coming to Hunziker, which is of course is not in your book, but those are interested you can learn. What is Hunziker reaction? You are taking a salt, silver salt, silver propanate. I am telling propanate because of 3 carbon. When you treat with bromine, what will happen? 1 bromo, you see, 1 bromo will go into methyl like this, ethyl bromide, the other bromo will go here and carbon dioxide will be released. That's all. So, last one is Finkelstein reaction. He has prepared iodide using iodide compounds. He has prepared iodide compound using iodide. When you use sodium iodide means what will happen? I will go inside and the Br will come out. Then slowly you learn the catalyst for all corresponding reaction. You see this one, for this it is a dry acetone, carbon tetrachloride, for that only heating, for this only pyridine. Okay. Next one, Sand-Meyer reaction. Sand-Meyer reaction. Sand-Meyer reaction means you should select benzene diazonium chloride. This is, you should be keep at low temperature. Okay, when this is treated with HCl, it will give C6H5Cl plus N2. This N2 will be coming out individually. Then what will ask me, sir, what about this Cl? You told me this Cl will add to this one, giving the phenyl chloride, okay. This will escape, okay. What about this Cl? This Cl will react with this H to form HCl. But we don't write this HCl because you will be confused. Why? You are treating with HCl, the product auto HCl. So that's why we don't use HCl and all. So, okay, there is another one. When you use HBr, you will be getting the correspondent bromide. When you use HCl, chloride, HBr, bromide. Suppose if they ask you Sand-Meyer reaction, of course there is one more one in Sand-Meyer. When you use CN, when you use KCl, you will be get cyanide. So, okay. When they ask you Sand-Meyer reaction, what you have to do? You have to see the catalyst. That's all. You see, these are the catalysts selected for Sand-Meyer reaction. Don't read the sentence and all. You can write your own sentence. That's left to you. Then there is one more reaction. Sir, if they ask for Gattermann, if they ask Gattermann reaction, this is meant for Sand-Meyer reaction. Suppose if they ask Gattermann reaction means what you have to do, you change the catalyst alone for these two and remove this reaction. That's all. Change the catalyst. What catalyst? For Gattermann means only copper. If you use only copper means Gattermann. If we use cuprous chloride, cuprous bromide, etc., it is a Sand-Meyer reaction. Okay. Next one. But this reaction you are going to learn again in nitrogen compounds. Okay. Now, next one you are going to see Woods Fittig and Woods Fittig. Having three, Woods Fittig, Woods Fittig. So, okay. First, I will write the common reaction for that. You see, this is a common reaction for Woods Fittig. You always try to prefer common reaction, then it will be very easy to write. You see, 2 sodium will remove this 2 bromide, so that these two are combined to form any alkane. That's all. This is common reaction which is meant for Woods fatigue, etc. Now, suppose if they asked Woods reaction, Woods always likes alkyl, like methyl, ethyl. He likes always alkyl. So what you have to do? You just write any alkyl. Don't see the book. You prefer any alkyl as you like. That's all. The product will be methane. That's all. The product will be ethane. Suppose, sir, I want to write another one or any other one. You can write. Somebody may choose ethyl. Here also ethyl. So, what will be the product? This one. But this is how should name? N-butane, because you have to expand this formula like this. Don't say diethyl, it is N-butane. So, okay, this is meant for Woods reaction. But how they use in the question? If a staff wants to test your knowledge, means how will he ask you? Like this. How will he convert methyl bromide to ethane? Like this they will ask. Or how will you convert ethyl bromide to N-butane? So, how you should answer this question? You see, here is 1 carbon, here is 2 carbon. When a carbon number doubles 1 to 2 or 2 to 4, then you should have the technical mind of using Woods reaction. What is the purpose of Woods reaction? It increases the number of carbon in the case of the products. Okay, this is Woods reaction. Suppose if they ask you phytic reaction, what about the phytic reaction? This is the phytic. You see, the phytic always likes phenyl. So, you change into phenyl, that's all. You change into phenyl, that's all. This is phytic reaction. What was the name of the compound? Biphenyl. The compound name is biphenyl. If somebody asks you, what's phytic? Then what do you do? This is for phytic because he likes phenyl, and this is for Woods because he likes alkyl. So, the product will be like this, toluene. Phytic means phenyl bromide, Woods means methyl bromide, they combine to form toluene. So, this is how we should learn Woods phytic reaction. Okay, next one. After Woods reaction, we are going for Friedel-Crafts reaction. Friedel-Crafts reaction. Whenever you see this name, Friedel-Crafts means you should have this catalyst in your mind, that is aluminum chloride. You should have this mind of aluminum chloride. So, okay. What is Felicaps reaction? There are two types. One is alkylation of Felicaps and the other one is acylation in Felicaps. Don't forget, what do you mean by acyl? Acyl means this group. This group is called acyl. Okay. Now we will see Felicaps reaction. You take that chlorobenzene, because of alkylation, you should select alkyl like methyl chlorides, and in the presence of anhydrous aluminum chloride, the methyl will join them. But already I informed you in the previous one, that is, it prefers ortho group or para group. It belongs to ortho para directing. So, one in the ortho, other in the para. What is the name? You write which you like as per book or anything. For example, this is toluene, orthochlorotoluene, parachlorotoluene. Okay. Next one, acylation. When they tell acylation means, you see, just you add this group. This is acylation. But here, be careful. Don't write like this. Don't write like this. It's wrong. Sir, when they ask acylation, I am just writing like this. It's wrong. Why? Because in this case, this CO is attached to the benzene ring, not methyl. So, be careful in writing the compound like this. You see, COCH3, that's all. Maybe in your book, it may be given like this, because I never used to follow the book, so that, but maybe they may use double bond and all. Don't use double bond. You write perfectly, mainly simply. That's very important. So, this is the answer. Similarly, for para also write the answer. One for ortho, other para position. Okay. These are first level important questions regarding this halo, alkanes, etc. Now you are going to see the, one more thing reaction, I forgot to write. Dow process. This is also first level. What is the Dow process? What does it say? You see, it converts chlorobenzene to phenol. It converts chlorobenzene to phenol. It treats with sodium hydroxide in the presence of 623 Kelvin, 300 atmosphere. First, it gets sodium salt. Which on treatment with acid gives phenol. This is Dow process. But basically, if you watch this reaction, you see Cl comes out, OH goes inside. It's very simple. But why they gave the name Dow process? The name of the scientist who found out. Because it is not very easy to remove the Cl from the benzene ring. He struggled very hard. You see the condition for this? From this you can understand. It takes 300 atmosphere to remove that Cl. Why? Because the bond between the benzene ring and the chloride is very, very strong. That's why they called us Dow process. You see, this is chlorobenzene. This I already gave the name in the common names. Okay, what is the name? Sodium phenoxide. I gave like this while explaining how to name the compounds. Sodium phenoxide. This is all you know, phenol. So, okay. Next one, you see, if you have the same reaction for this compound, it is very easy. It doesn't need any high pressure, temperature, etc. You see, no condition. Why? It is not Dow process. It is not Dow process, but it is very easy. Why? Because of the CH2 group. Because of this CH2 group, the bond between, the attraction between the ring and the chloro is totally diminished. That's why it is very easy to remove, but here it's not easy. That's why they told us Dow process to recognize him to find out the compound. Okay, now we are going to the second level. Now we are going into the second level. In second level, first one is, I am writing this chlorobenzene. You see, when I write a chlorobenzene, I am going to teach about electrophilic substitution. When I say the electrophilic substitution means, what you should understand? Sir, we should first know the directing group. Chlorobenzene belongs to orthopara. That is very important. You learn the common itself. So, when anybody gives chlorine means, what you should do using the catalyst? What you should do? Sir, orthochloro, like this, and parachloro. You see, orthochloro, parachloro. So, okay, if somebody gives nitration, orthonitro, paranitro. If somebody gives sulfonation, sulfur SO3H, para SO3H. These are the reactions you should learn casually. That's why I just put it in the second level. Okay, next one. Next one is the with cuprous cyanide. Answer is very easy. You see, CN enters. But the reaction is difficult, so that they use some condition, DMF and some temperature. DMF with some temperature, that's all. Cyanobenzene or phenyl cyanide. Suppose when you treat with ammonia, you can guess the answer. HCl will be removed, you see. That's all. The product will be aniline. The product will be aniline. And this is the catalyst. Suppose when anybody asks, chlorobenzene to aniline means NH2 can be introduced by using NH3. That's all. You have this technique. Then, you see, this is chloroform. When treated with that, in the presence of light, it gives poison gas. That's all. It gives a poison gas. Carbonyl chloride, It's of course highly dangerous, poison gas. Then last one, you see, suppose these are reactions in your book, so that I am touching it. Somebody asks like this. With the UV light, etc. How to answer this question? First, I told you, don't forget, whenever you use chlorine, what will happen in the general reaction? If you have doubt, go through the general reaction. H will be converted into Cl. Whenever you use chlorine, H will be converted into Cl. This is a concept. Wherever you show me any reaction, there you can see H will be converted into Cl, provided you should use chlorine. So, what you should do? You take this H, last one, slowly you write by following that one. Slowly you write like this. That's all. You see, what's the difficult writing this? And there is one more option. You can ask me, sir, you have taken the last one, terminal one. Sir, why can't you try the middle? Okay, that is also possible. That is also possible, middle. You see, that's all. But watch, what I am doing is, when I write Cl, I just removed one hydrogen. That is important. Okay, why are not taking this H? Because these two groups are similar. They are same. From this side, it is the second one. From this side, the second one. So, removing this one or this ones are similar. That's all. The product is over. Okay. When they asked for this one. Okay, what is the name of this compound? Having 4 methyl surrounded by a carbon. First, count the carbon, pentane. Okay. But because of this approach, it is called as neopentane. Neo means carbon attached to 4 methyl in all sides. Okay. When you treat with chlorine, what will ask me? Sir, we are going to remove this one or this one or this one. What will answer? All are similar. All are similar. So, you can remove any hydrogen. It is known as neopentyl chloride. The compound name is neopentyl chloride. These are the second level regarding the organic chemistry. Sorry, how to name this compound? Very simple. You count the carbon 1, 2, 3, 4. 4 means butane. First one, so 1 chlorobutane. Second one, 2 chlorobutane. How will you name this compound? Whenever they ask you, just count the carbon. 3. Or you can name like this, neopentyl. Sir, I want to know the IPAC name is, I am already told you, I will teach you later on. But I will hint you here. See, 1, 2, 3, propane, 1 chloro, 1, 2, 3 means 2,2-dimethyl propane, 2,2-dichloropropane. Okay.